This is the experimental apparatus for the heat exchanger basics lab. 3 different heat exchangers are available on the unit. One small brazed plate heat exchanger, one large brazed plate heat exchanger, and a shell and tube heat exchanger. Though it doesn't look like it, the small brazed plate heat exchanger has the same heat transfer surface area as the shell and tube heat exchanger. This allows you to compare the performance of both types of exchangers. Normal building water flows on the hot side of the exchanger. It comes from the cold and hot building water from the wall. Each line, cold and hot, is then fed into the bottom of 2 different rotometers. After exiting the rotometers at the top, the 2 lines are combined into one stream using a Y connector. This single line now enters the hot side of the heat exchanger. This can be confusing to students. The hot stream in the exchanger is a combination of building hot and cold water. This allows you to use the rotometers to combine the streams in different proportions to get different inlet temperatures for the hot side. The hot side outlet stream exits to the floor drain. The fluid on the cold side of the exchanger is chilled water from the campus heating and cooling plant. It is colored pink and is a closed system, so that the cold side outlet stream from the exchanger is returned to the campus chilled water system at the wall. Rotometers are used to control the flow. Open the needle valve to the left to increase flow. The flow rate is read from the top of the float. Right now, the needle valve for the chilled water is completely open, and the max flow rate is slightly above 2 gallons per minute. However, the pressure in the campus chilled water system varies from day to day, so the maximum flow rate may be lower or higher when you use the system. In general, it's safe to assume that you can get at least 1.5 gallons per minute on the cold side, even on the worst days. Remember that the hot side stream is created by combining hot and cold building water to achieve the desired temperature. Closing the cold water and opening only the hot water will give you the maximum hot side temperature. In this case, the flow rate of the hot water is 2.5 gallons per minute. If I wanted to achieve 2.5 gallons per minute at a lower temperature, I could reduce the hot water flow rate below 2.5 gallons per minute, say 1.5, and open the cold water rotometer to 1 gallon per minute. Some fine-tuning of both rotometers may be required as each affects the other. The hot and cold sides of the exchangers have different connections to prevent mixing of the streams. The cold side connections are made of black plastic. The hot side connections are made of stainless steel. 4 temperatures are measured in the experiment. The brass tags identify these as T1, T2, T3, and T4. The 2 top temperatures on the meter are for the hot side inlet and outlet streams, T1 and T2. The bottom 2 are for the cold side inlet and outlet streams, called T3 and T4. The brazed plate heat exchangers are designed for counter current flow. The stickers on the top of these units depict the flow pattern. Notice that F3 goes to F1 and F2 goes to F4. This indicates that one stream enters at F3 and exits at F1, while the other enters at F2 and exits at F4. Since F3, the inlet of one stream, and F2, the inlet of the other stream, are at opposite ends of the exchanger, this unit operates in counter flow. In our configuration, F3 is the inlet of the hot side stream and has stainless steel connections. F2 is the inlet of the cold side stream and has black connections. The specification of F3 to F1 as the hot side stream and F2 to F4 as the cold side stream was arbitrary and chosen when the apparatus was built. The 2 sides could have been swapped during construction without changing the behavior of the system. The shell and tube heat exchanger can be operated in either counter or co-current flow. Notice in this configuration that T1 is on the right. By swapping the quick connect fittings, the inlet and outlet on the hot side can be changed so that T1 is now on the left.